So this one is January 2016, Unit 6. The first part normally is about identification of the ions. So there is inorganic salt, which is having a cation and anion. Complete the table. Observe the appearance of A. It appeared to be a brown powder. So if it appeared to be a brown powder, this gives an idea that there should be a transition element. So which part of a periodic table it belongs to? So it belongs to D block, because transition element, they have a colored compound, their compounds are colored. So if it was a white solid, then we can say either it will be S or P block element. Then dissolve A in the minimum volume of concentrated hydrochloric acid. So we dissolve in hydrochloric acid, a yellow solution form. So when we dissolve in hydrochloric acid and it form a yellow solution, what this gives an idea, because it turned out to be either iron chloride or copper chloride. These are yellow in color. So the formula of a cation in A, whenever HCl is added and we are getting a yellow solution form. So what this gives an indicator, it might be copper ion or it might be iron 3, because copper ion or iron 3 ion with chloride, they will form a yellow solution. So either copper 2 is there or iron 3, because iron 3 chloride solutions are yellow, or copper 2 chloride solutions are also yellow. Copper 2 sulfate is blue, but copper 2 chloride is yellow. Then gradually diluting a portion of a solution with distilled water. So we are adding a water. The yellow solution turned dark green and then it turned pale blue. The formula of cation A is confirmed. So it means the oxidation numbers are changing. Remember, copper plus 2 can be yellow. Then copper plus 2, when it is like copper 2 with a chloride ion, it is yellow in color. But copper 2, which is forming a complex with water, that is blue in color. So we are gradually diluting a portion of a solution with distilled water. So it turned, the yellow solution first turned dark green, because ligands are changing, and at the last, then it turned to be pale blue. So which substance is pale, which complex is pale blue when it's in making a complex with water? So that is copper ion. So it is confirmed that the cation, the positive ion which is present here, is a copper. The next part, place a sample of A in a test tube and heat strongly. A pale green gas is evolved, which turn the damn blue litmus red and then bleaches. So this gives an idea that the gas which is given off is a chlorine. So if chlorine gas is given off and then it bleaches, so a white solid residue remain. So what could be a white solid or a residue? So this gives an idea, because a chlorine gas is given off, so anion, the negative ion, will be chloride ion, because if chlorine gas is given off, it means the chloride ion is present in the substance. Then we add hydrochloric acid to a white solid, the solid which is left here. We add hydrochloric acid, the colorless solution form. The white solid could be, so because copper 1 ion solutions, they are white. Reason for that is when it is having a D shell complete, it does not form a colored compound. So whenever copper 1 ion is there in the solution will be colorless. The compound will be white solid, but when we make a solution, it will be, so if it is a copper 1 chloride, if it is copper 1 chloride, it will be colorless solution. If it is copper 2 chloride, it will be yellow solution. So this white solid was actually copper 1 chloride, and when we dissolve, so the white solid, which is, this is copper 1 chloride or CuCl. Shake the mixture and colorless solution become blue. Why the colorless solution become blue? Because the copper 1 ion, when we shake, Oxygen is there. It is oxidized due to the presence of oxygen, and it turned out to be copper 2. The solution might change color. There might be two reasons for a solution to change a color. One is by due to a ligand exchange. Sometimes the ligand exchange, the color changes. And second one, there might be a change in oxidation number. So in this one, when we have a copper 1 chloride solution and we shake, so copper 1 ion is oxidized to copper 2 ion, and the solution now turned to copper 2 chloride. And that copper 2 chloride, because copper 2 chloride is yellow in color, but when we continuously shake, the ligand also exchange and it will become hexa copper complex. That's why it is blue in color. So the reason here, what type of reaction caused this to change a color? So that is oxidation. So due to oxidation, the copper +1 changed to copper 2, and then the complex change, a ligand exchange. But because the main reaction, main color change is due to change in oxidation number. That's why we are saying the reaction is oxidation. So the next one, suggest a further test to confirm the identity of the cation. The cation was copper 2 ion. We want to identify, confirm. So how we can identify the positive ion? So simple test, we can add sodium hydroxide. It will form blue precipitate, and when we add an excess, the precipitate does not dissolve. Or we can add aqueous ammonia. It will give blue precipitate, and in excess, the precipitate dissolve to form a deep blue solution. So any one of them you can mention. You can mention add sodium hydroxide, NaOH. First, we add 5 drops. When we add 5 drops, because the copper ion is there, it will give blue PPT. Then we add an excess. Excess means more than enough. So it will form blue PPT will remain insoluble, does not dissolve. Suggest a test to confirm the identity of the N ion. So how to test the chloride ion? Add nitric acid. The reason why we add first nitric acid, because maybe some carbonate ion might be present in the substance, so it will not give a positive result. Like carbonate ion also. So to remove the carbonate ion, first add nitric acid, and that is followed by silver nitrate. And as a result, it will give a white PPT. Then give the formula of the N ion that give a yellow color to the solution described in B, and green color described in C. So what was the reason for a yellow color? And basically, if you remember the formation, the chemistry of the copper, so copper 2 chloride solutions, when the chloride ion is a ligand, so when 4 chloride ion are attached, it will give a yellow color. But when 3 are attached, 3 chloride ion are attached, it will give a green color. So, in both cases, it is copper 2. So this is CuCl4, and copper is +2, chlorine, each chlorine is -1, 4 chlorine will be -4, so this will be -2. And green color is due to CuCl3. So copper is +2, so this will be -1. So remember the complex chemistry of copper, that when 4 ligands of chlorine are attached, it is yellow in color, but when 3 are attached, it is green in color. And when completely the ligand exchange, like all the chloride ions are replaced by water molecule, it will give us the blue solution. Then question 2. Isoprene is a colorless liquid and peppermint smell found in cranberry. Structure is given. The 2 functional groups present, name the functional group, describe a chemical test and observation. So which 2 functional groups are present? As you can see, carbonyl group is there, C double bonded with O, and there is C double bonded with C, so alkene is there. So the two functional groups which are present here, one is carbonyl, another one is alkene. And for carbonyl, we can use 2,4-dinitrophenyl hydrogen, and for alkene, we can use bromine. So C double bonded C, you'd have to write the name. I'm just saving my time to just writing the formula, but you have to write the name carbonyl and alkene. And test will be the bromine water, and here we'll have 2,4-dinitrophenyl hydrogen. This will change from brown. If I'm using bromine water, so it will change from brown to colorless. And this will give orange PPT. Then it is having a several proton environment that could produce a peak in its proton nuclear magnetic resonance. One of the environment is circle. The circle proton environment produces a low resolution NMR. State and explain the splitting you expect in this peak in high resolution. So number of the splitting depends on n plus 1. Like n is the total number of the neighbor carbon plus 1. That will be the total distribution. So we have to check how many neighbors are there, and according to the neighbors, we will identify how many hydrogen are present in the neighbor carbons. So when you check this one, this neighbor, this 1, 2, this does not have any carbon hydrogen. When you check this neighbor, it also does not have, this neighbor also not having directly hydrogen. So means n is 0. If n is 0, so n plus 1 will be 0 plus 1. It will be 1. So it will give us singlet. Because the number of the splitting pattern depends on number of hydrogen in the neighbor plus 1, n plus 1. So this will give us singlet. Then one of the structure of is given. The low resolution NMR indicate clearly if any proton environments are identical. So we have to identify the proton environments which are identical. So what we can do, because like basically the number of the proton environments or total number of the proton environments we have to identify. So this will have 1, 2, 3. So this will have 1 hydrogen. This will have 3 hydrogens. This will have 2 hydrogen. This will have 3 hydrogen, and this will also have 3 hydrogen. So how many hydrogen indicate if any proton environments are identical. And on the structure, circle each other proton environment. So what are the proton environment? Look, this is one proton environment, but this is not identical to any other. This is CH2, this is also CH2, but they are not identical. Why they are not identical? Because this CH2 next is carbonyl group, but this CH2 the next is not carbonyl group, so they are different hydrogen environment. So this is another hydrogen environment, this is another hydrogen environment. This CH3 is not identical to this one because this is next is alkene group is there. So this CH3 is different, but these two are identical. So 1, 2, 3, 4, 5 hydrogen environments are there.